Hey guys, welcome back to my channel, and this is Varun. So in the previous few sessions, we have covered some of the very essentials and basic methods that helps us evaluate our decision making through critical value method and p-value method. And we also did a deep dive into each with the help of lot of examples. Now in this session, we will see some common types of errors by categorizing the errors, and then we will see the other forms of distribution called as t-distribution and see where t-test is used. So first we will talk about the types of error that can occur during our decision making process. So the first error can be where actually the null hypothesis is true, but we decide to reject the null hypothesis. In that case, this is called a type 1 error because we are rejecting the true null hypothesis. The other type of error is type 2 error, where we fail to reject the null hypothesis where actually the null hypothesis is false. And the rest are the correct decision, and therefore there are no errors because we are failing to reject the null hypothesis when actually the null hypothesis is true, and we decide to reject the null hypothesis when null hypothesis is false. Now let us take the similar example of a person going through a trial in court. Now, as discussed previously, there can be two possible outcomes of this. Either the defendant is found innocent or he is found guilty. Now, as human errors can occur, there are high chances that there will be different types of error in this case also. So can you guys just pause this video and guess the type 1 error and type 2 error in this example? Now in this table, you can regard the column as the true value and the individual row keys as the court's decision. Now we already know until the trial happens and the decision is made, the defendant is innocent. So this becomes as the null hypothesis here, and the other one, which is defendant is guilty, becomes the alternative hypothesis. Now when the true value is that defendant is innocent and we try to reject the null hypothesis, that is we are trying to say that he is particularly guilty, then this is a type 1 error, right? And when the true value is that defendant is guilty and we fail to reject the null hypothesis, that is we are saying that the null hypothesis is true and we are actually giving a verdict of the person not found guilty, then this will be a type 2 error and the rest becomes correct decisions. Now we will see another example. So here the null hypothesis is amount of medication in heart pill that is ideal, or in other words sufficient to cure the heart diseases, and the alternate hypothesis is amount of medication is very high. Okay, and after our calculation we fail to reject the null hypothesis, that is we say that the medication is proper in the heart pill, but in actuality the amount of medication is very high and people are dying from over medication. So can you guess which type of error occurred here? So exactly, this is a type 2 error. Now sometimes what happens is type 2 error is high if the difference in the assumption of population parameter and the true parameter is very small. So in such situations, there is high possibility that we might not reject the null hypothesis even though it is false. Okay, so in those cases, we will say that the amount of medication in the pill is proper. And so here type 1 error will be inversely proportional to the type 2 error. Now in order to have both type 1 and type 2 error in data, we will have to take two large data. Okay, and the power of hypothesis testing becomes 1 minus beta, where beta is the type 2 error. Now we can demonstrate this kind of a situation with the help of a graph. So you can see that innocent suspects and criminal suspects are lying here in the graph, which is a normal curve in both the cases. And when we observe the area under the curve for the innocent suspects, which is crossing the criminal suspects, we can mark that area as type 1 error. And when criminal suspects cross over innocent suspects, it is a type 2 error. Now as we have seen earlier that both are inversely proportional, then reducing the probability of type 1 error may increase the probability of making type 2 error. Now if jury becomes very liberal in acquitting the people on trial, there would be a higher probability that an actual criminal is able to walk free. Now we have a question. Suppose that the null hypothesis is that a particular new process is as good as or better than the old one. So can you just pause the video here and tell me what will be the type 1 error here? So if you guys can recall, the type 1 error occurs when we decide to reject the null hypothesis when actually the null hypothesis is true. Okay, so the type 1 error here will become the old process is better than the new one when it is actually not. Now guys, let's understand a situation and come up with a solution taking a scenario of a person who has disease or not. Okay, so here null hypothesis becomes person does not have disease, as this is the status quo, and alternate hypothesis becomes person has the disease. Okay, now if the null hypothesis is rejected, that means if the patient is ill and is treated, and if the treatment doesn't have any side effects, then can you tell me which type of error is most feasible for us? Or in other words, it is better to increase which type of errors probability? Is it type 1 or type 2? So guys, if you have noticed that we are taking the assumption that if the treatment does not have the side effects, let's say that it is similar to a treatment given by Ayurveda which does not have any side effect. So in that case, providing the treatment when not needed is the ideal situation, because in that case we will not leave behind any of the persons who actually have disease, but we are ready to compromise on people who does not have disease and they can undergo the treatment. So that scenario is type 1 error, where we decide to reject the null hypothesis that the patient does not have the disease when it is actually true. So that is all for today guys. I have not covered T distribution and test in this session, as I wanted to cover it along with the other similar kind of test in the next session. Hope this session has given you a clarity on how hypothesis testing is done end to end along with the error scenarios. If you guys like my content, please don't forget to support my channel by simply subscribing it and encouraging me. It takes a lot of effort and motivation to create these videos, so please don't stop giving me feedback. Thanks for your time and patience. I hope to see you soon in the next session. Until then, keep learning and inspiring. Cheers.